Here's an interesting thermodynamics problem about Carnot engines from JEE Main. This problem appeared in the JEE Main online exam on 12th April 2014. Let me read the problem for you. A Carnot engine absorbs 1000 joules of heat energy from a hot reservoir. It rejects 600 joules of heat energy during each cycle. We need to find two things: the efficiency of the engine and the temperature of the cold reservoir. Let's start by visualizing what's happening in a Carnot cycle. Here's a visual diagram of our Carnot engine system. At the top, we have the hot reservoir at 127 degrees Celsius. The engine absorbs QH equals 1000 joules from this hot reservoir. In the middle, we have the Carnot engine that does the work. The engine performs work W during each cycle. At the bottom, we have the cold reservoir or sink, with temperature Tc which we need to find. The engine rejects Qc equals 600 joules to the cold reservoir. This is the complete setup. Let's write down the important formulas for a Carnot engine. First, the efficiency of any heat engine is defined as work output divided by heat input. By energy conservation, the work done equals heat absorbed minus heat rejected. Combining these, we get efficiency equals QH minus QC, divided by QH. For a Carnot engine specifically, the efficiency also equals 1 minus Tc over Th. Remember, temperatures must be in Kelvin for this formula. Now let's solve the problem. Step 1, let's calculate the efficiency of the engine. We'll use the formula efficiency equals 1 minus QC upon QH. We know that QH equals 1000 joules and QC equals 600 joules. Substituting these values into our formula, 600 divided by 1000 equals 0.6, therefore, the efficiency equals 0.4 or 40%. Excellent! The efficiency is 40%. Now let's find the temperature of the sink. First, let's convert the hot reservoir temperature from Celsius to Kelvin. Now we'll use the Carnot efficiency formula, efficiency equals 1 minus Tc over Th. We already found that efficiency in previous step equals 0.4 and Th equals 400 Kelvin. Substituting these values into the formula. Rearranging, Tc over 400 equals 1 minus 0.4, which is 0.6. Therefore, Tc equals 0.6 times 400, which gives us 240 Kelvin. Converting back to Celsius, 240 Kelvin minus 273 equals minus 33 degrees Celsius. Perfect. The temperature of the sink is minus 33 degrees Celsius, or 240 Kelvin. Let's summarize our complete solution. Looking at the answer choices, we found efficiency equals 40% and temperature of sink equals minus 33 degrees Celsius. The correct answer is option B, 40% efficiency and minus 33 degrees Celsius. Let's review our key steps one more time. Step 1, we calculated efficiency using QH and QC. Step 2, we used the Carnot efficiency formula to find the sink temperature. This problem tests your understanding of Carnot cycles, efficiency calculations, and temperature conversions. Did you solve it correctly? Remember, Carnot engines are the most efficient heat engines possible. If you found this helpful, like and subscribe for more thermodynamics problems.